Example, classical probability with combinations. Suppose your class of 20 students has a drawing to send 3 students to Cancun for spring break. That sounds fantastic. If the names of the winners are drawn randomly, what are the chances you and your 2 best friends will be the 3 students selected? The first thing I'm thinking about is this with replacement or without replacement? I think it's without replacement. And the reason I think it's without replacement is because once I select a person to go on this trip, I don't put their name back into the drawing to be selected again. And then I need to decide, since it's without replacement, that means I could use the NCR and the NPR, but I need to know which of the two is it. Does order matter or does order not matter? And since I'm looking at you and your 2 best friends, all 3 of you are going to get a trip regardless of the order you're chosen, so order does not matter. And because order doesn't matter, that tells me I need to use the NCR. And NCR is how many are in the group, in the big group, and how many are you choosing. So we have 20 students in the big group, choose 3 winners, and the number of combinations for that is going to be 20 PRB, slide over there to NCR, choose 3, and it's 1140. That's how many possible combinations they are. We want the one combination that has our group of 3 people that we're interested in. So 1 out of 1140, 1 divided by 1140, and that gives me 0.000877. I'm going to write a lot of decimals because I have a bunch of leading zeros. There's one other way that you could have used to find this probability, and so I'd like to show you that right now. If you think about each position being drawn, first we have 20 students before the first student is drawn, and you could pick any of you or your 2 best friends for that first position. So 3 out of the 20 could be drawn. And then just like with the fundamental counting principle, we'll multiply all these probabilities together. And the next drawing for the second person who gets to go, now we only have 19 people left. And since we're assuming we already drew one of our people in the 3 that we want to go, we only have 2 left out of the 19. And then for the third position, we have 18 students left, and just our last friend has to get chosen for that one. When we multiply this one out, we get 6 over 20 times 19 times 18, and that's 6,840. And when I do 6 divided by answer, remember that, then I end up with 0.000877, just like before. So this is another method of finding the probability. The NCR is much quicker. You just have to remember the 2 criteria: without replacement and order doesn't matter. And if you remember that and you figure it out for your problem, you can use the NCR. What we are saying then is that the probability that you and your 2 best friends will be the 3 students selected is 0.000877. Not very likely.